All right, so we want to find the equation of an ellipse where the co-vertices are 12, 0 and negative 12, 0, and the major axis length is 30. So what I would recommend is to first just draw like a sketch of what this is showing. So the co-vertices are going to be opposite from each other. So if we draw an axis like left to right, since these are x coordinates, we're going to have one over here, negative 12, 0, and the other one at 12, 0. Now, since the co-vertices are at these points, that means the center of this ellipse is going to be midway between these 2 points. So midway between negative 12 and 12 will just be 0. So the center is at 0, 0. And let's keep in mind that this is going to be the minor axis, or the small axis, because this is a major axis, has a length of 30. But this length is only going to be 24. So the major axis is going to go vertically through the center. This will be the major axis. And if it has a length of 30, that means from here to here is 15, and then from here to here is 15, because that's half of 30. So then the top vertice will be at 0, 15, and the bottom vertice will be at 0, negative 15. Now, if this is the minor axis, remember the distance from the center to one co-vertice is equal to the value of b. And then, so b will be 12. So from 0 to 12 is 12, obviously. And then since this is the major axis, that means that the distance from the center to the vertice at the top is equal to a. So a will be 15. So we're going to have our ellipse be vertical because it's more tall than it is wide. And so the a squared values will go underneath the y term. So let me just write in general. We'll have y minus k squared over a squared plus x minus h squared over b squared is equal to 1. This will be our general equation. So we just fill in the k, h, a, and b. The center is at 0, 0, so k and h is 0. So we can just write the top as y squared plus, and then x squared will be there. A squared, so we're going to have 15 squared. 15 squared is 225. B squared, b is 12, so b squared is 144. And that'll be our equation. And now let's look at this other example. So we have vertices at negative 8, 3, 4, 3, and foci at negative 4, 3, and 1, 3. So again, I would draw, a sketch to see what this looks like. So negative 8, 3, and 4, 3, this is going to be a horizontal axis. So something like this. We have one at over here to the left, and the other one to the right at 4, 3. These would be our vertices. I'll put let me just write that V1. We can put this as like V2 to represent vertice 1, vertice 2. So then the center is going to be midway between these 2 points. These are horizontally across from each other. So these are 12 units away because negative 8 to 4 is 12 units away. So half of 12 is 6. So 6 away is the center. So that means that the center will be at negative 2, 3. Now, since these are the vertices, that means the distance from here to here represents our value of A, which is going to be 6. Remember, this is the major axis, or you say major axis, big axis. Now, our minor axis, or vertical axis, is going to be up and down. So we need to figure out where the top and bottom co-vertices are going to be. Now, since this is our smaller axis or a minor axis, the distance from the center to a co-vertice is equal to b. So we need to figure out what the value of b is to know where the co-vertices are. So for that, we're going to use the relationship of a, b, and c. In an ellipse, we can relate a, b, and c with the equation a squared is equal to b squared plus c squared. Our a is 6, so a squared is going to be 36, which is 6 squared. We don't know what b squared is, so we're going to leave that as. Now for c squared, we can figure out what c is from our foci. Our foci are negative 5, 3, and 1, 3. So negative 5, 3, let's say over here, let's call that F1, negative 5, 3, and then 1, 3, let's call that F2, will be our foci. So the value of C is the distance from the center to the foci along this axis. So the distance from the center to this point, we go from -2 to 1. So that's 3 units away. 3 units to the right, 3 units to the left. So C is 3, so C squared is 9. So then we can solve for B squared. Taking away 9, we'll get B squared is 27. So then B will be the square root of 27. So B will be about 5.2-ish. And we actually don't even need to find the coordinates of them, of these points. We could, but might as well go ahead because we're just trying to find the equation. But B is about 5.2-ish. So then this will be 5.2 units above the center, which will be about -2, 8.2. And then this will be at about -2. 3 minus 5.2 will be about -2.2. And so, since this is a horizontal ellipse, that means the a squared will go under the x. So again, we're going to have, remember, the x minus h squared over a squared plus y minus k squared over b squared is equal to 1. That'll be our general equation. So we just fill in the h, k, a squared, and b squared. H is -2. So then we're going to have x minus -2, which is the same as x plus 2, squared on there. K is 3, so we're going to have y minus 3 as that part. And then a squared is 36. And since it's a horizontal ellipse, we'll put the 36 under the x. And the b squared is 27. And so our equation for our ellipses will be there.